Good morning, girls. I hope that you're enjoying your online learning at home, lying by the pool, sitting by wherever you sit. I hope that you're enjoying it. So today we're looking at simplification using reduction, and in the example that you see in front of you, there are only acute angles. We know they're acute because remember pi over 2 is 90, so any angle less than pi over 2 will have a higher denominator, and it's still pi in the numerator. So in this case, we can simply replace all the numerators and the denominators functions with their corresponding special angles. For your benefit, on the right-hand side, circled with the green circle, oval, whatever you want to call it, I've given you the degree equivalent so that you can see how it matches to the special angles. Right, so in this case, we can firstly say that sine pi over 6 is sine 30 in degrees, which makes it a half. Then tan pi over 4 is tan 45 degrees, which makes it 1. Then in the denominator, sine pi over 3 is sine 60, which makes it root 3 over 2. And tan pi over 3 is tan of 60, which is root 3. Right, simplifying, we get a half at the top, and we get 3 over 2 at the bottom. And if we tip in times, it gives us a half times 2 over 3, which equals a third. Okay, so now we're going to move on to an example where the angles are not acute. They are not pi over 2, they're greater than pi over 2, so we have to use reduction formulae in order to reduce them. Right, so firstly, let's look at the cos 7 pi over 3. We need to look for the multiple of the denominator that is closest to the coefficient of the numerator. So we have 369. So clearly, what do you think is closest in terms of the multiples of 3 to 7 pi? Yes, it's 6 pi. Well done, girls. So we have cos of 6 pi plus pi over 3. Then for the second one, what is the closest multiple of 3 to 5 pi? It's clearly 6 pi. So we have sine 6 pi minus pi over 3. So let me just tell you what we've done here. We've found the multiple, but then we've had to correct it so that it still has the same value. So the closest multiple for the cos was 6 pi, but we need 7 pi. So we said 6 pi plus pi, which we know is 7 pi. For sine, 5 pi over 3, the closest multiple of 3 was 6 pi. So we said 6 pi minus pi. Now in the denominator, we're going to say tan, and the closest multiple is actually 9 pi. And minus pi to give us 8 pi over 3. And then tan, the closest multiple of 4 to 3 is 4 pi. So it will be 4 pi minus pi over 4. Right, so the numerator simplifies in such a way. We have cos. Now if we divide the 3 into the 6 pi and the pi, we get 2 pi plus pi over 3. Now look at this 2 pi. That's the same as 360. So you've already learned your reductions in core maths. It's a 360 plus reduction. Then the sine, we have sine 6 pi divided by 3 is 2 pi. There's a 360 again, this time minus pi over 3. Then in the denominator, tan. Now here's what's interesting. We get 9 pi divided by 3, which is 3 pi, which is not 2 pi, which is 360 degrees, or pi, which is 180 degrees. But 3 pi, if we subtract 2 pi from that, we're subtracting a full revolution. So we can actually just make that pi minus pi over 3. Then we get the tan. 4 pi divided by 4 is pi minus pi over 4. Do you see now how those are all now special angles, your acute special angles? Okay, so if we work from this step, you'll see that we've got cos 2 pi plus pi over 3. That's in quadrant 1, where cos is positive. So it's cos pi over 3. Let's bracket that. Then we have sine 2 pi, which is the same as 360, minus pi over 3, which means it's negative, because sine is negative in quadrant 4. Okay, then in the denominator, tan pi minus pi over 3, that's the same as 180 degrees minus pi over 3, so tan is negative in quadrant 2, so we have negative tan pi over 3, and then tan pi minus pi over 4, also in quadrant 2 where tan is negative, so we have negative tan pi over 4. So at this point, I'll see that there are 3 negatives, which means that the answer is going to definitely be negative, and then we just work with the ratios themselves. Right, so cos pi over 3 is a half. Sine pi over 3 is root 3 over 2. Remember, we're disregarding the negatives because we've already dealt with the signs. Tan pi over 3 in the denominator is root 3. And lastly, tan pi over 4 is 1. Right, so let's tidy this up at the moment. We can say we know our answer is negative. And let's look at the numerator. So we have root 3 over 4 times, and at the bottom we have root 3. If we tip and times that, we have 1 over root 3, which means that the root 3's cancel, and our answer is negative a quarter. Right, so if you look at the example that I've put in front of you, the border of a garden pond consists of a straight edge, AB, of length 2.4 meters, and a curved part C is shown. So the curved part C is part of the circumference. The curved part is an arc of a circle, center O, and radius 2 meters. Find the perimeter of the pond. Right, so what they want is the distance from here all the way to here, and including this edge. Right, so firstly, we need to find the angle AOB. All right, and we can find that angle by using the cos rule. Right, so firstly in green, you can see that we need the size of angle AOB, which if we use the cos rule gives us 1,287 radians, which I've put in the diagram. Okay, so next, we've worked out that the angle AOB is 1,287 radians, and to work out the minor arc, so the minor arc is what would be here, of AB, is r theta, the radian measure, at least the radius times the radian measure in the center of the circle, which is 1,287. So 2 is the radius times 1,287 gives us 2,574 meters. So we know that the full circumference of the circle is 2 pi r. So if we subtract this value from 2 pi r, we'll get the value of AB, major arc. Right, so let's do that. So in a different color, just so that I know color coding helps you girls, we'll say that the major arc of AB, remember that refers to this portion, is equal to 2 pi r minus 2,574. And that gives us 9,99 meters. And that's obviously where we substituted the radius as 2 meters into this point to get the answer of 9,99 meters. Right, so the full perimeter is equal to the 9,99 meters, which, remember, represents A to B, plus the 2,4 meters, and that gives us a total of 12,39 meters.